Hello everyone, I am Dr. Jagadha, Associate Professor in the Department of Mathematics, Institute of Aeronautical Engineering, Hyderabad. The topic for discussion we selected problems on double and triple integrals, in which in detail we will discuss about the definition of double integrals, what is the formula which is defined for the double integral, triple integral, and we will solve the problem using double and triple integrals. So the double integral, that is, this double integral which is used to find the area of a particular region using double integration, we will evaluate. So that is the importance, the role the double integral is playing. Coming to the point of triple integral, to find the volume of your region, using the triple integration, we are evaluating. So this is the importance, the role playing of this triple integrals. The formula which is defined for double integral is, that is, here the capital R defines, it is a Cartesian form, that's what it is. It is x and y, the dimensions are there. So the capital R, it is nothing but the region. So the double integral, if x and y, the dimensions are mentioned, then it is f of xy into dx, dy or dy dx. That's what here it is written. Dx, dy, this is the innermost integration. This is the outermost integration. So the first with respect to x or with respect to y, according to the limits, how they are defined, on that basis the integration will be done. If they are in Cartesian form, these formulas, this or this, anyway we can use it. If they are in polar form, the radius and angles, the functions are defined as a function of radius and theta. Here the innermost, here which is given radius, the outermost, the theta angle is defined. If they are in polar form, for the double integral, we will use this formula. Coming to the point for triple integral, so the three integrations, innermost, middle and outermost. So the f of x, y, z, dz, dy, dx. So here we did the innermost with respect to z, the middle one with respect to y, and the outermost with respect to x. Here the triple integral which is in Cartesian form. If it is in polar form, the formula, here it is there, it's a triple integral f of r, theta, y. So dr, d theta, dy. So this is can be used for if it is triple integration in polar form. Now we will solve a problem, evaluate double integration, r square sine theta dr d theta over the cardioid. That is, satisfying this condition, we will get a shape, the geometrical shape, which is nothing but cardioid. That is, leaf shape it will be. So the condition is given r equal to a of 1 plus cos theta above the initial line, that is above the x-axis. So this is the condition which is given. Using that, we have to solve this double integration r square sine theta dr d theta. Now, it is double integration. That is the reason x-axis. So here x-axis is there. This is the y-axis, 2-dimension. The origin we represented, we named it as O. We put it here x-axis, naming, and this is y-axis. Now, the leaf shape, how we have drawn. So the word which is given cardioid, so it is a leaf shape, but exactly it is satisfying condition we have drawn it. How we have drawn this, we will have a look. Now, it is given r equal to a of 1 plus cos theta. First, we know it, the cos values. What are the values we know it? Cos is 0 equal to 1. So, if we are taking, suppose the theta is 0, then a of 1 plus cos 0 is 1. So, it is playing, we got it, 2a is the answer. So, it gives an indication that from origin, it moves up to 2a distance. Otherwise, we can, because polar we are doing, the radius from origin it moves up to 2a it moves. From the distance it is moving up to 2a. Now, if it is pi by 2 the angle, then a of 1 plus cos 90. Cos 90 is 0, we know it. It's nothing but a. So, from here, it's coming, and when it is touching this 90-degree angle, the distance here from here, Jitru, is a. That is, this is double of this is 2a, this is a. So, now we are here. So, at 90, here we are there at the distance of this a. Next, the theta, we are putting pi. Then a of 1 plus cos pi, cos 180 degree. Cos 180 degree, we know it is minus 1 the value. So, 1 minus 1, we are getting 0. So, from here, where it starts, it is coming back to the origin. So, satisfying this condition, so we have drawn from here to the point 2a, here it moves and it stops. But it is given cardioid, the full leaf shapes we are drawing, and this is the background of drawing this figure. Now, what they are questioning us, above the initial line you have to take. So this, which region we want it now? This is the region we want it. Because above the initial line it is given. So this is the initial line. So above that region we are taking. This particular point, the angle is 0. This particular point, from here to here, the angle is 90 degree. But up to here, the angle is 180 degree. So the angles are mentioned, theta equal to 0, theta equal to 90 degree, and theta equal to 180 degree. Now, we have to, this region we have to. So we are going to take this curve which is formed now. We substituted in this theta 0, this point, pi by 2 this point, pi this point. So this is the curve r equal to a of 1 plus cos theta. That's what it is kept here. So to calculate this one strip we are taking. This is from here the radius we want it. This region to calculate from origin to touching this curve. What is the radius? Radius from where to where? And theta from where to where? These 2 points to be very clear to us. Now, the strip we are naming as OA. So, reading the question, what are the points are given, according to that we drawn the figure. Now, just know what we have drawn the figure in size, a small one we kept it here. This is our given question. The region of integration is the part of, because it's a complete, the curve is complete, but we wanted only this because in the question above the initial line only calculate it is given. So that's what it is, a part of this curve, r equal to a of 1 plus cos theta. Now the cardioid r equal to a of 1 plus cos theta above the initial line, theta equal to 0. Limits we have to know. That is, this integration r starting from where? It starts from here. This is the origin. That is, we can see it here. From here the radius. Here too it moves and touching the curve. That's what 0 to, this is the condition of the cardioid, what is given in our problem that we have taken. Suppose the curve which is given, so according to that the shape will be, then from here according to that the extension or very less we will be doing. So from 0 to, this is the, from r 0 to r equal to a of 1 plus cos theta, we got it. Coming to the point about to the angle, that is theta. The theta from here it's nothing but theta equal to 0. From here the angle it moves pi by 2, but again it moves the initial line touching, that is theta equal to pi. So our angle 0 to pi. Yeah, we know it. This is our given question. So according to our problem condition, we have drawn the diagram. So now we have to evaluate this given question. What is we are asked to do it? R square sine theta dr d theta is written as it is. So just now we discussed about it. That is, r starts from 0 to touching the cardioid curve a of 1 plus cos theta. So it is the integral is a function of theta defined for r. So we have to do integration with respect to r first. Then, so the innermost one, it is integrated with respect to r. Then outermost, the other possibility is the outermost we are going to integrate with respect to theta. Now, the innermost we are going to do integration with respect to r. So those terms we put it in the separate bracket to avoid careless mistakes. So we have done it first. The separate we have taken. The idea is we will do the integration. The result what we are going to get in this particular place we will substitute. So the innermost integration, it is written separately. We know it r square dr. So the r square dr, the simple integration formula, that is integral x power n dx equal to x power n plus 1 by n plus 1. Fine. So here our n is playing a role 2. So r cube by 3. Yeah, fine. R cube by 3. Our upper limit is a of 1 plus cos theta. What about a lower limit? Lower limit is 0. Now we are going to substitute the upper limit, that is a of 1 plus cos theta. So our r is taking the position of the upper limit, that is a of 1 plus cos theta. It's nothing but a cube 1 plus cos theta the whole cube. This is our formula minus, this is lower limit, that is r place we substituted the lower limit value 0. This 1 by 3 is kept as it is because that is nowhere connected. It is participating the limit substitutions because we are doing integration with respect to r. So this is the integration we are concentrating. That is that there's a middle one separate we have taken and we did the integration and we got this is the result. So this result, this innermost integration is replaced. So after replacing, now what are the simplifications? Is there anything? So we are noticing a cube by 3 is a constant. So before the integral, it is placed. So next integral 0 to pi 1 plus cos theta the whole cube sin theta d theta. The next step is, so we can see here. So now this is the before step. Here we are noticing one minus sign is there. Before the step it is only sin theta. Whereas in the next step, if you notice, the sin theta, it has become minus sin theta, and a cube by 3, it has become minus a cube by 3. That is, we did minus 1 by minus 1. That is, multiply and divide by minus 1 we did. Why suddenly we introduced this? But mathematically it is balancing because multiply and divide we did. It is nowhere. Otherwise minus into minus also plus. Anyway we can take it. Mathematically it is correct. It is obeying balancing. But why we have to do it? Because the integration, it is a very difficult one. Which is the formula available with us. Those laws using, we can do this integration very easily. So this is the formula, that is f of theta the power n. The first derivative of f of theta, if it is multiplied by this f of theta power n, then we can write f of theta power n plus 1 by n plus 1. So we can see it here. This part we are taking as f of theta. So our f of theta equal to 1 plus cos theta. F dash of theta is 1 is constant, it is 0. So minus sin theta. So to apply this formula, we need minus sin theta. That is the reason here the sin theta we replaced we changed into minus theta to fit this formula for our integration. Now, it is exactly obeying this formula. So, our f of theta, here this is a bracket, f of theta power n plus 1. Our f of theta we have taken 1 plus cos theta. Our n is 3, so n plus 1 is 4 divided by n plus 1. So 0 to pi. So minus a cube by 3. So this 3 into 4 put together minus a cube by 12. So this is 1 plus cos theta the whole power 4, 0 to pi. Now we will substitute the values. So minus a cube by 12, it is there, 1, here cos theta, that is theta place, it is taking pi. Cos pi, it's nothing but minus 1. So 1, here minus 1 we are getting. That is the reason upper limit, the value which is obtained as 0. This is formula minus, and the theta is replaced by 0. So 1 plus cos 0, it's nothing but 1. So we are getting 2. But 2 power 4 is there. So 16 we are getting. So this minus and this minus put together plus, then 16 by 12, the lowest form we are giving 4 by 3 a cube. So we completed the double integration problem. Now we will move to triple integration, which is in Cartesian form. Now evaluate. So if you're noticing the innermost integration from 0 to 1 minus x minus y. That is the innermost integration is a function of x and y. That means z is depending on this x and y. Here, which is defined as a function of x. The last one is constants are given. This triple integration, we will solve it now. So the given, here it is the triple integration as it is the question, the presentation we have given here, writing given, just reproducing the question here. The innermost limits depend on x and y. So compulsory, we have to do the innermost, this integration with respect to z. But in the question it is given dx, dy, dz is given. No. According to this limits, what they are defined, it is defined for z equal to 1 minus x minus y. So it is must to do the integration with respect to z only first. So if it is z equal to, then the next one is y equal to. So the last one is dx. So we have to change this with respect to dx, dy, dz. It should be written dz, dy, dx according to the limits, values, range. What is the defined for the limits? According to that, the order we have to maintain. Now, so this is the integration. Now we will concentrate it. So the first one, the z, this part we concentrated. We are going to concentrate. That is, the integration is now x plus y plus z plus 1 power minus 3 dz. We know our simple that our integral formula is x power n dx it is there. That is x power n plus 1 by n plus 1. Our n is minus 3, we know it. So x plus y plus z plus 1 the whole power minus 3 plus 1 by minus 3 plus 1. So x plus y plus z plus 1 whole power minus 2 by minus 2. This is the answer. We got it for the innermost integration with respect to z. This is the result we got it. That is only mentioned here, this minus 1 by 2. And we got it x plus y plus z plus 1 the whole power minus 2. We know it, a power minus m, it's nothing but 1 by a power m. According to that, it is written 1 by x plus y plus z plus 1 the whole square, and the limits, the lower limit is 0, upper limit is 1 minus x minus y. So now this is minus 1 by 2. Now we are substituting the upper limit in the place of z. So this minus 1 by 2, we kept it before the integral because anyway they are treated as constant. X, y as it is written, whereas this place z which is replaced by 1 minus x minus y. That's what here it is written. This plus is written as it is, 1 is written as it is, the whole square. So we completed the upper limit integration, we completed. This is the formula minus. Now lower limit we have to concentrate. That is x, y, this is becoming 0. So the leftover it is written x, y and 1. Z anyway it has become 0 after substituting the lower limit value. So completely the innermost integration integrated, we substituted upper and lower limits. This is the result, we got it. Now, is there any simplifications for this? Here, these two terms are getting cancelled and 2 square, it has become 4. So 1 by 4, this minus sign as it is, this term also it is written as it is. Now we will move to the middle integration with respect to y. So this is the last step, we got it. So now 1 by 4. So they integrated with the y, it will become y by 4, which will become y by 4. Next, this integration, that is integral of x plus y plus 1 power minus 2 dy. So x plus y plus 1 minus 2 plus 1 by minus 2 plus 1. We are getting x plus y plus 1 power minus 1 divided by minus 1. So this minus 1, this minus 1 put together it will become plus 1. And the power also 2 will be reduced into 1, that is minus 2 plus 1 minus 1. So minus 1, but we have written that down, it has become plus 1 according to the exponential law. Now the lower limit is 0, upper limit is 1 minus x. So now we can see it here, minus 1 by 2. This y place it is there. we substituted the upper limit, that is 1 minus x by 4. So now here 1 is written as it is, x is written as it is, this y is replaced by the upper limit 1 minus x, the 1 is written as it is. So we completed the upper limit. In the place of u, substituted 1 minus x. Now this is the formula minus. The next, the lower limit, the y place. So this is completely vanished. But here we are substituting 0. So the leftover is 1 by x plus 1. That's what it is written here. More simplifications, noticing these two are getting cancelled. Now this is as it is. The integral is written as it is. 1 minus x by 4. This simplification is 1 by 1 plus 1, 1 by 2. The minus sign as it is. This term also as it is. So we completed the middle integration. Work also completed. Now the final one, the outermost integration with respect to x. So the minus 1 by 2 integral 0 to 1. If you are noticing here 1 minus x by 4, this is written, and just this minus sign we took it inside. So it has become minus 1 by x plus 1. So this is the last step, we got it. Now we will do the integration, that is, this is nothing but dx by 4. So that is what dx integral is, x by 4. This is x dx. X integral is x square by 2, but already 4 is there. So 4 2s are 8. Here this 1 by 2 it is written, but dx integral is x. Dx by x plus 1, the integral is log of x plus 1. It is written, the minus sign is as it is. So now, so this minus 1 by 2. So we are going to substitute the upper limit, that is in the place of x. The upper limit value is 1. So it is becoming 1 by 4 minus, this is 1 by 8 plus 1 by 2. This is minus log of 1 plus 1. It has become log 2. So we substituted the upper limit in the place of x, substituting 1. We got this value. So now here, this is the limit, that is the formula which is used for the limit formula. That is upper limit minus lower limit. So the lower limit is x value is 0 in the place of everywhere. Here 0, 0, 0. Here substituting we are getting log 1. That value also 0. So in the place of x, the value which has been taken, that is the lower limit value 0. Totally it has become 0. So now this minus 1 by 2 and taking LCM of this, that is 8, here 4 is there. So 2 minus 1 plus 4. So the 6 minus 1. So the totally 5 by 8 minus log 2. We will come to a conclusion of this topic, that is problems on double and triple integrals. First, initially we have taken this problem, evaluate r squared sine theta dr d theta over the cardioid, and mainly we focused on, this is the condition of the cardioid, r equal to a of 1 plus cos theta, and the condition also regarding this particular problem, it is given above the initial line. According to this, the diagram which has been drawn. So this particular region to find, we concentrated what is angle, angle from where it starts, where it ends, even radius also, what from where to where. For that, a strip also we have drawn. The strip name is OA. With that help, the problem we solved it. One more problem also, that is a Cartesian form for the triple integration we have taken. So the innermost one we have seen, it is a function of x and y. So z is defined. So we have to do the innermost integration with respect to z first, but it is given here dx. So we have to change. That is also we concentrated. So we have taken double for polar form, triple for Cartesian form, and we discussed it. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.